Hi everybody. In this video we're going to talk about 13.1.2, which is going to be graphing linear equations. Let me get my iPad set up here again. Try not to bump my laptop. Here we go. All right, linear relationship. So linear relationship is, guess what? It's going to graph a straight line. So linear relationship graphs a straight line, and it can be represented by a table, by a graph, or an equation. We have several different types of forms that we can use. One is going to be our standard form. And the standard form for a linear equation is going to be ax plus by equals c. So I want you to think about how that compares to our standard form of a quadratic equation. Remember that was ax squared plus bx plus c equals 0. So you're going to see a few things that look different, right? So we've got our a and our b here. They're going to be our coefficients of our x and our y variables. And then c is going to be our constant term, just like c was our constant term over here. And then a and b, guess what? They're still our coefficients of our x squared and our x variables on the standard form of a quadratic equation. All right, so we've also got slope-intercept form, which is going to be y equals mx plus b, that we've talked a lot about already, where m is the slope, b is the y-intercept. We've got a horizontal line. I'm hoping you remember that's the one that starts with a y, and it's going to equal y equals some constant term. And a vertical line is going to be x equals some constant term. And so those are just kind of our general equations for the different types of linear equations and linear relationships that we have. Okay. So in this video, we're going to really focus on 3 different ways that we can graph the same equation. And so one of the hardest parts I think about this lesson is that you are going to be asked to graph the same exact line, but 3 different ways. And so it's really important that on your paper, when you're working these out for quizzes or for homework or for exams, that you are showing me on paper that you know how to do each of these 3 different ways. So for the first way, it's going to be graphing by creating a table. So the first thing we're going to do is we're going to make a 4-column table. So we're going to make a 4-column table, and we are going to choose a value for x. Next, we're going to substitute that value into our equation to see what the y value is. Next, we're going to plot the ordered pair that we just found. And then we're going to repeat this step until we have at least 3 ordered pairs to graph. Then we're going to use a straight edge. So use any straight edge that's around. You can sometimes just get out your student ID and use that for your straight edge to draw your line. You can use the side of a notebook, a side of a book. You can use a ruler. Any of those things are going to work great for a straight edge. So using a straight edge, we're just going to draw a line through the points you plotted. This little asterisk here is coming in from up here. So it says make a 4-column table and choose a value for x. Well, sometimes it's actually going to be helpful to solve our equation for y and then plug something in for x. And so that's what that note is going to talk about. So it's going to say sometimes it's helpful to first solve the equation for y, and then substitute values for x into the equation. Other times it makes more sense to substitute the values for x into the original equation. And we're going to look at some different scenarios for both of those situations. All right, so in this method, we're just like in this graph right here, we're just going to work on graphing this using a table. So first, what I would recommend on this one is I would go ahead and just solve for y. You absolutely don't have to, that's not a requirement, but I personally would solve for y because I know what's coming next in the next step for graphing using our slope-intercept form. So I am going to go ahead and I'm going to subtract 4 from both sides. And then I'm going to get 2y equals negative 3x minus 4. And then I'm going to divide everything by 2. So then I'm going to get y equals negative 3 halves x minus 2. And so this is going to be my equation I'm going to work with. So then I'm going to make a table. I'm going to make a 4-column table. It's going to be important that you are making a 4-column table as well. So the first column is going to be my x values. The next column is going to be my equation. The third column is going to be the y's. And the fourth column is going to be our ordered pair that then we're going to go and graph. All right, so for our x values, I personally like to pick x values that are strategically chosen based off of the equation I'm given. So for example, I have a 2 in the denominator. I've got that negative 3 halves, and I want that 2 to cancel out. So I'm going to pick any multiple of 2 that will also land on the grid that's given to me. So I have a 10 by 10 grid here. So I want to make sure I'm not picking something like 20 because an x value of 20 is not going to fit on my grid. So I typically pick something like negative 2, 0, and 2, or I'll do like 3, 0, and negative 3, and something like that, depending on the type of equation I'm given. So that's what I'm going to choose for this one. I'm going to go ahead and put negative 2. And so then in this next line, we're going to do negative 3 halves all over, or not all over, times negative 2 over 1 minus 2. And so we're just working on our steps here. So here, these 2's are going to cancel out. You have a negative right here times another negative. So it's going to be a positive now. So now we've got a positive 3 minus 2, which is going to give us 1. And so then I'm going to be graphing the ordered pair of negative 2, 1. And I'm going to come over here and I'm going to graph it. Negative 2, so I'm going left 2, up 1 for negative 2, 1. And then I'm going to do that, repeat that process. So now I'm going to do a 0, and then I'm going to do a 2. So now I'm going to have negative 3 halves times 0 minus 2, which is going to give me 0 minus 2, which gives me negative 2. And I'm going to get 0, negative 2. So 0, negative 2. And then we are going to do the last one of 2. So then I've got negative 3 halves times 2 over 1 minus 2. So these 2's are going to cancel out. And then I've still got negative 3 minus 2, which is going to give me negative 5. So then I'm going to get 2 comma negative 5. So I'm going to go 2, negative 5. And at this point, what I would do is check your points and make sure that the slope is the same between all of the ordered pairs. So like on this one, I'm going to go up 3, left 2, excuse me, and I'm going to do it again, up 3, left 2. So that just tells me that, you know, there's some consistency there, and I probably did that right. So now you're going to get out your straight edge. You're not just going to eyeball it like I'm doing here. I want you to get out your straight edge and then draw your line. All right, now we're ready for the next method. And note, it's going to be the same exact equation. So we're going to take this equation and we're going to be graphing it again on the next page, but using a different method. So method number 2. So here's method number 2. We're going to be graphing by putting the equation into slope-intercept form. So first step, put the equation into slope-intercept form. So in other words, solve the equation for y. Then we are going to identify what the y-intercept is. And the y-intercept is going to be in the form of 0, comma b. So those are the things you're going to fill in those blanks while I'm grabbing out my paper. So we're going to identify the y-intercept from the equation, and it's going to be 0b, and then we're going to plot that point. So then starting from our y-intercept, next we're going to use the slope in order to graph at least 2 more points. So starting from the y-intercept, use the slope to graph at least 2 more points. And then what's the note there? Slope can be expressed several equivalent ways. So it can be expressed like, for example, if we have negative a over b, we can also write that as negative a over b, or we could write it as a over negative b. So for example, let's say we've got a slope of negative 1/3. That slope of negative 1/3, you can write it as negative 1 over 3. You can write it as 1 over negative 3, or you can just say it's negative 1/3. They're all going to be equivalent. What else? Oh, the last one. Using a straight edge, guess what? We're going to draw a line through the points you plotted. All right, so we're going to use these steps in order to do this graph now. So first step says put the equation into slope-intercept form. So we would have just done that on the previous page, but I don't have it to reference to, so I'm just going to do it again. So I'm going to subtract 4, and then we've got 2y equals negative 3x minus 4. We're going to divide it by 2. And then we've got y equals negative 3/2 x minus 2. And then you can verify, did we get the same answer, negative 3/2 x minus 2? Looks like it. So I'm going to guess that we did that right. So the next thing it says for our step letter B is it says identify the y-intercept from the equation. And so it's going to be 0b. So my y-intercept, it's going to be in the form 0b. Recall that this is our y-intercept, right? So it's going to be 0 100% of the time. And my b is going to be negative 2. So I'm pulling that down. That's going to go in this spot. The 0 is always going to be there no matter what. And now we're supposed to graph that point, 0, negative 2. Then the next step, it says starting from the y-intercept, use the slope to graph at least 2 more points. So I'm going to also identify my slope. I would like you guys to do that as well. You're going to write it down. Common error. Students will write negative 3/2 x for their slope. That's not your slope. That's giving me negative 3/2 and an x. Your slope is just the coefficient of your x. Don't put the x on there. So we're just doing negative 3/2. All right, so now we're going to use our slope to graph at least 2 more points. So let's say I go down. If I go down 1, 2, 3, left 2, there's going to be a point. And I'm going to go down 1, 2, 3, left 2. So I could have graphed it there. I could have also gone up, right? We could go 1, 2, 3, left 2. And then we'll put a point and we could go up 1, 2, 3, left 2. So your choice, go up, go down, but you need at least 3 ordered pairs on your graph. So get out your straight edge, draw your line. Next method. This is the method that students tend to struggle with the most because they haven't done this method before. So make sure if you have questions on this, you ask me in class the next time I see you because I want to make sure you're understanding this. So this method, this is our method number 3 that we're going to use. Graphing by finding and plotting the x and y intercepts. So think about this. Intercepts, what does that mean? It means our graph is going to cross the x at some point. So this would be our x-intercept, and this would be our y-intercept, right? So the y-intercept, I'm going to make it a different color. Y-intercept is going to be red. My x-intercept is going to be black. I have no idea where that x-intercept is at that point, other than I know that the x value is negative, right? It's like going to the left, so it's negative x. And then I do know for sure that the y value is 0, right? So it's x something 0. Well, what do I know about the y-intercept? So I know that we've got something, like we've got, what's our x value? Our x value is always going to be 0. And then on this particular case, I know that my y is some positive number because it's above the x-axis, right? So we know for sure these two pieces. We know for sure that x-intercepts, our y value will always be 0. And we know for y-intercepts that our x value will always be 0. We're going to use that to our advantage in this kind of method where for our two intercepts, we are going to plug 0 in for y. We're going to solve for x. And then we're going to plug 0 in for x. And then we're going to solve for y. And that's how we're going to find our two intercepts. So those are the blanks that we're going to fill in down below, just kind of walking you through that process. Okay, so the x-intercept is going to be the point. What do we already know? It's going to be x comma 0, where the line intersects the x-axis. To find the x-intercept from the equation, we are going to substitute 0 in for what? You should know this. What position is it in? We're substituting 0 in for y, and we're solving for what? For x, because we don't know what that is. This is our unknown, right? That's the question mark. This is for sure going to be 0. Then we're going to plot the point. For the y-intercept, I bet you could fill this in, right? The y-intercept is going to be the point 0, comma y, where the line intersects the y-axis. So to find this point from the equation, we are going to substitute 0 this time in for which one? For x. And we're going to solve for which one? For y. Then we're going to plot the point. Then we're going to use a straight edge. We're going to draw a line between the two intercepts. So notice this is the one that you only have to graph 2 points on. You don't have to graph 3 because guess what? For a line, we can have at most 2 intercepts. So if your line only has 1 intercept, so we're going to talk about when we can actually have that happen. So if your line only has 1 intercept, then you need to use the slope of the line to graph an additional point. So I want to ask you, what's a scenario that we can only have 1 intercept? So think about that. Like, when are we only going to have 1 intercept? And we can have it in a few cases. So think about like if we have a vertical line, right? We're only going to have 1 intercept. We're only going to have an x-intercept. What if we had a horizontal line? So a horizontal line is only going to have 1 intercept at our y-axis. And then we've got a line that could go through the origin, in which case it's also only going to have 1 intercept. It could also go the other way. Like we could have it go like that, and it's going to be just at the origin. So those are some scenarios where we're only going to have 1 intercept. All right, so here we go. Again, you don't have to solve it for y. I'm just going to solve it for y because that's what we've done on the other ones, and we would have already had that equation. So I'm going to pull the equation from here where it says, because it's the same equation we're starting with. So our slope is going to be -3/2 minus 2. So I'm going to write that in. Y equals -3/2 x minus 2. So that's the equation we're going to start with. And here I go. I'm going to do the x-intercept first. And I want you to write out what is the general format for the x-intercept. It's going to be x comma 0. And then our y-intercept is going to be 0 comma y. And so we're going to write that out, and then we're going to follow the process. So looking at what we're supposed to do, for our x-intercept, it says to find it, substitute 0 in for y and solve for x. And by writing the general form, it tells you what to do. It says substitute 0 in for y, solve for x. So that's what we're going to do. So I'm going to write in y equals -3/2 x minus 2. We're substituting 0 in for y, and we're solving for x. So this time we're going to have 0 equals -3/2 x minus 2. I'm going to add the 2 over. So then I'm going to get 2 equals -3/2 x Now I'm solving for x, so I'm going to divide both sides by -3/2. You could also just multiply by the reciprocal, right? You can multiply by -2/3 because that's the same thing as when we're dividing by that fraction. You multiply by the reciprocal. So that's what we're going to do over here too. We're going to do -3/2. And then we are going to get x equals, I'm going to do a little fraction work for a second. So it's going to be 2/1 times 2/3, and it's negative. And we are going to get x equals -4/3, or -1 1/3. All right, so then I want you to write that up as an ordered pair. So it's going to be -1 1/3, comma 0. Because this is the x that we just found right there, right? So that's what we're going to look at. So if I was you, if I got a number like -1 1/3, I would maybe be wondering, did I get the right number? Let me go back and check. So I would go back and look at my other graphs and say, does it look like the x-intercept could be about -1 1/3 right here? Sure. Yeah, especially because I eyeballed my line and I just drew it free-handedly rather than with a straight edge. Same thing over here. This one looks actually even closer. This one looks like it could be at -1 1/3. So I think we're on the right track. So let's try the y-intercept and find out what happens there. So the y-intercept, again, we're plugging 0 in for x, and then we're solving for y. So we're going to take our equation and we're going to write y equals -3/2 times 0 minus 2. So -3/2 times 0 is just going to be 0, right? So then it's going to be y equals -2. Then you need to write it as an ordered pair. So we're going to write that as an ordered pair, and it's going to be 0, -2. So we're going to go and plot that at 0, -2. I forgot to plot my other point of -1 1/3, 0. So it's going to be about right there. We're just going to eyeball it as close as we can get. And then you're going to use your straight edge and you're going to draw that line. And you need to extend it. So I've had students before just draw the little line segment between those 2 points. Don't do that. Extend it through those points, put arrows on the end because you're drawing a line, not a line segment. All right, so those are the 3 methods. Now we're going to try several examples doing all 3 of those methods. So for our first method, we've got y equals -2.5x. What I might recommend for you to do is to change this one into an improper fraction. And so what I would do is think about, I'm actually going to come up here and do it because otherwise I'm going to run out of space. Is I would go like this, -2.5 is going to be 2 1/2, right? X, and then if we're changing that into our improper fraction, we're going to have y equals -5/2 x. All right, so now we're going to put that into, that's the equation we're going to use for our different parts here. So again, remember the first method is table method. So we're going to make a 4-column table, and we're going to do x, and we're going to do our equation, in which case we've got -5/2 x. Then we've got our y, and then we've got an ordered pair. So that's what we're filling in. Again, I'm going to pick some strategic x's to cause this right here to cancel out. And so I'm going to pick -2, 0, and 2 again, because my denominator is 2. So I'm going to do -2, and so I'm going to have -5/2 times -2/1. Those 2's are going to cancel out. That negative times the negative is going to give me a positive. So it's going to be a 5/1, which is just going to be 5. So then I'm going to have -2, 5. So I'm going to go graph that. -2, oh my goodness, this is small. -2, 5. And I'm going to graph another point. So I'm going to pick 0 to plug into my equation so then I can go graph it. And so then I'm going to get -5/2 times 0. And guess what? 0 times any number is going to give us back 0. So then I'm going to have a point at the origin. And then I'm going to do a +2. So then I'm going to have -5/2 times 2/1. Those are going to cancel out. I'm going to end up with a -5. And so I'm going to get 2, -5. So 2 and then -5 for that. And then use your straight edge and draw your line. All right, next method is using our slope-intercept form. And so I'm going to go ahead and just use the equation we've already worked with. Y equals -5/2 x. So my y-intercept is going to be what for this one? What's the b on this one? Right, so normally we have something over here that would be the b. So what is it? And it should be 0, right? So if it's not showing up, it's going to be 0. So our y-intercept 100% of the time is always going to start with 0, something. So this time our something is falling in right here and it's going to be 0, 0. So that's my y-intercept is at 0, 0. And now we're going to use the slope to graph 2 more points. So I'm going to use the slope and you need to identify it and write it down on your paper. And it's going to be -5/2. So I'm going to go down 1, 2, 3, 4, 5 over 2, 1, 2. And it's negative, so you have to be careful which way you go. Then we're going to go, I could actually go down again. 1, 2, 3, 4, 5, 1, 2. And then draw your line. And definitely use your straight edge. This graph is a little bit harder because it's smaller grid. So it's easier to get a larger margin of error, right? All right, x and y intercepts. X-intercept is going to be x, 0. And then our y-intercept is going to be 0, y. So we're going to do this one first. So we're plugging 0 in for y. We're solving for x. So that's what we're doing. Plug 0 in for y, solving for x. So I'm going to divide both sides by -5/2. I'm dividing this by -5/2. So I've got 0 over some number. 0 over any number is going to end up being 0, right? So, or you could also multiply -2/5 by 0, and guess what? It's still 0. So 0 equals x. So what that means is that this x here is going to be 0, and I am getting 0, 0 for my x-intercept. All right, so now I'm going to do my y-intercept. So my y-intercept is going to be 0, y. I'm plugging 0 in for x, and I'm solving for y. And so you have that scenario. And so y is going to equal 0, because -5/2 times 0 is 0. And so then my answer, this 0, is going to be the second 0. So far this method for this problem is not so helpful. It just gave us 2 points that are coinciding right on top of each other. And so it's not helpful. So what are we supposed to do again if we get only one intercept? And it tells you up here that if we only get one intercept, which is exactly what we had because we had this situation, we need to use the slope of the line to graph at least one more point. So we're going to do that. So we know our slope is -5/2, so we're just going to go down. Well, this time I'm going to go up. 1, 2, 3, 4, 5, left 2. And it's going to be right there. So then when you're looking across at all 3 of your lines, they should look exactly the same. And I mean same as in like same slope, same shape. Did we use different points? Yes. But is that a problem? No, because all of those points are going to lie on the graph of the line. So it's going to be fine. Okay, I gotta yawn again. Let's do our table method. Table method. So table method, we've got our x, we've got our equation. It's going to be 2/3 x. I think I'm trying to decide. Do I like to? Yeah, I'm going to change this one into a mixed number. This is the one that I like to change the y-intercept into a mixed number. And I'll tell you why here in a minute. And then it's going to be y, and then we're going to do our ordered pair over here. All right. So look at our slope and figure out, what do you think would be a good strategic x to pick for this one? Like, what are some x's we could choose that's going to cause that denominator to cancel out? I'm hoping you're saying -3 and 0 and 3 because it's going to cause it to cancel out. If you want to, I have some students that are like, I don't care if it's strategic or not. I'm just going to do like -2, 0, and 2 all the time. That's going to work for linear equations and it'll be fine. You're just going to get a little bit messier of y values, which is fine. You can still graph those. It's not a problem. All right, so here we go. We're going to, oh, not -2. We're going to do -3. So we've got 2 over 3 times -3 over 1 minus 3 1/2. So here the 3's are going to cancel out. I've got -2 minus 3 1/2, which is going to end up being -5 1/2. So we've got -5 1/2 here. And then we've got -3, -5 1/2. So I'm going to go graph that point. So -3, -5 1/2. So then our next one, let's do a 0. 0 is always super easy. Let's get that one done. So let's do 0. It's going to be 2/3 times 0 minus 3 1/2. So this is going to be 0 minus 3 1/2, which is going to give us -3 1/2. So we're going to plot that point, 0, -3 1/2. So let's go plot that point, 0, -3 1/2. And then our last one is going to be a +3 that I'm going to do. And so it's going to be 2/3 times +3 over 1 minus 3 1/2. The 3's here are going to cancel. Then we're going to have 2 minus 3 1/2. You're welcome to put that in your calculator, or you can just think about it and say, okay, if I have 2 items and then, or if I have 2 and I'm going to take away 3 1/2, well, how many do I have left now? It's going to be -1 1/2. All right, so then we've got the point 3, -1 1/2 there. So we're going to come over here to 3, down 1, and just 1/2 more. And then look at your points. Does it look like they line up in a line? Yes. If they don't, you might have made a mistake, and just go back and check your math. All right. Next one, we are doing slope-intercept form. So we're going to have y equals 2/3 x minus 3 1/2. Our slope is going to be 2/3, and the y-intercept is going to be 0, something. That something again comes from our equation right here, and it's going to be -3 1/2. So go and plot that 0, -3 1/2. So it's going to be 0, -3 1/2 down here. And then we're going to use our slope of 2/3. So you're going to go up 2, up 1, 2, right 1, 2, 3. Then you can do it again. Up 1, 2, right 1, 2, 3. And we can plot it over here. And then graph your line. We've got 3 points. Go ahead and graph it. All right, next method. X-intercept, y-intercept. So x-intercept, and use your other graphs to kind of guide you. It kind of looks like the x-intercept is going to be around 5. So hopefully that will be the case. Ooh, okay, stop yawning. All right, so now we've got x, 0. For our x-intercept, we're going to plug in 0 equals 2/3 x minus this time I think I'm going to do 7 halves. I like to work with our improper fractions when I have to solve for x. I'll just show you. So we're going to have 7 halves, and that's going to equal 2/3 x. And then I'm going to multiply this side by 3 halves, and this is why I want it as an improper fraction, because it's going to make my multiplication easier here. So these are going to cancel out. And then on the left-hand side, I'm going to get 21/4 equals x. And so then you're asking yourself, well, how many times is that going to go into 21? And it should be 5 1/4, which is, well, 5, and then you're gonna have 1 left over, right? And so it's gonna be 5 1/4 equals x. And so then you need to write it as an ordered pair. So it's gonna be 5 1/4, comma 0. So then it's gonna be 5 and just a tiny bit past 5. So right in there. And then we still need to do our y-intercept. So we already know our y-intercept should come out at -3 1/2, but we're still gonna make sure that we're writing out those steps. So we're gonna be plugging in 0 in for x, solving for y. So y equals 2/3 times 0 minus 3 1/2. And so that 2/3 times 0 is gonna go to 0 minus 3 1/2. And so y equals -3 1/2, as we predicted. So then write your ordered pair as 0, -3 1/2. Go plot that point at -3 1/2, and then draw your line between those 2 points. All right. So the one that I'm going to have you guys do is this one, number 3. So I'll have you guys try this one on your own. What I would recommend first is that you get it into slope-intercept form. So that part I'm going to make sure you guys are good with that part. So if I'm getting it in slope-intercept form, I would go ahead and distribute here. And so then we're going to get 2x equals -3y plus 6 for that. And then let's go ahead. I'm going to bring my 3y over. So I'm going to bring my 3y over, and I'm going to bring my 2x over as well. So now what I have, so this is going to go away, that's going to go away. So now what I have is I've got 3y equals -2x plus 6. And now you're going to divide by 3. So then your equation, I'm going to come up here. Your equation is going to become y equals -2/3 x plus 2. And that's going to be your equation you're going to use. So definitely make sure you've got that information written down on your paper. You've solved for y, and you're ready to go for this one. So you're going to do the table method, and then your slope-intercept form, and then your x-y intercepts. We're going to try the horizontal line here for our last graph. I'm so sorry. I wish I could say it's my bedtime, but it's not. I've got some more work to do tonight, so not yet. All right, so number 4 is going to be y equals 4, and we are still going to do our table method. And then we've got, so I want you to think about, like, what's the slope for a horizontal line? Horizontal line, the slope is 0. So remember, it's going to be y equals mx plus b. And so taking this one and putting it into slope-intercept form, it's going to be y equals 0x plus 6 for that, because we already have the 6 here. So that's actually our y-intercept. And then our slope is going to be 0. So that's what I'm going to put in here. I'm going to put 0x plus 6, and then y, and then I'm going to have the ordered pair over here. All right, pick an x, any x, as long as it lands on your grid. I'm going to choose -8. So 0 times -8 plus 6 is going to give me 6. So I'm going to get -8, 6 for my ordered pair. And so I'm going to go graph that, -8 and 6. And then my next one, I'm just going to choose 5. 0 times 5 plus 6. Well, 0 times 5 is 0, plus 6 is, guess what? 6. So now I'm going to plot 5, 6. So 5, 6. And I'm just going to pick 0. Why not? So 0 times 0 plus 6 is going to give me, you guessed it, 6. So it's going to be 0, 6. Go up there and plot that line, or plot that point, and then we're going to graph that line. That is really messy. You guys can do better than me. All right, slope-intercept form. So we've got y equals 0x plus 6. My slope is going to be 0. My y-intercept is going to be 0, 6. So go graph that point at 0, 6, and then use your slope, right? So maybe I'm going to do 0 over 2, just for kicks and giggles. So that means I'm going up nothing, and I'm going to go right 2. I'm going to go up nothing, right 2, up nothing, right 2. And we're going to plot that. You could have gone over 1, you could go over 3, you could go over 4. I don't care what you go over, just make sure you get 1. So let's try some x-intercepts. So an x-intercept is going to be x comma 0. And so we are plugging 0 in for y, and we are solving for x. Well, something interesting happens here. So here we get 0. 0 times x is going to give us what? It's going to give us 0 plus 6. And then 0 plus 6 is going to give us 6. Does 0 ever equal 6? No, it doesn't. Well, what does that mean? So we're trying to find an x-intercept. Look at your graph. Do we have an x-intercept? No. So this time, this means no x-intercepts. Okay, so let's look at our y-intercept. So our y-intercept is going to be 0, comma y. So we are going to be plugging 0 in for x, and we are solving for y. So y is going to equal 0 plus 6, and y equals 6. So then we're going to be graphing the point, put it as an ordered pair, 0, comma 6. Well, here we go again. We got a scenario where we only have one ordered pair. So you use your slope of 0 to graph an additional point. So I'm just going to use my slope of 0. I'm going to graph an additional point, and we've graphed our straight horizontal line. All right, so we've finished the graphing. Now we talk about a couple more things in this topic where we look at ordered pairs as solutions, and this page goes by pretty quickly, and then we've got a couple of word problems down here that we'll look at the very end. So let's look at these as ordered pairs as solutions. And so what we're going to fill in the blanks there is that it's going to be every point on the line is a solution. That's solution. That looks super messy. Is a solution to the equation that graphs that line. So what that means is that any line, any ordered pair that falls on the graph of this line, if I come up with the equation for that, like if I said, well, this is going to be y equals negative 2/3 x plus 4. If I picked any ordered pair that lies on the graph of that line, when I plug it in for x and for y, this side will equal this side. That's what that means. So what we're going to do in the problems below is that we're going to determine if the following ordered pairs are solutions to those respective equations. So what that means is that we're being asked, is this a solution to this? Or alternatively, does this point lie on the graph of this line? Well, this little paragraph in here talks about like things that we can do. We could graph it. We could sure go graph this line, and then we could see, does 2, negative 13 lie on the graph of that line? Well, sometimes that takes quite a while, and then we don't always have graph paper available to us. And so we can just actually graph, or we can actually just check that algebraically and run an algebraic test where we say, well, let me just plug it in and find out. So if 2, negative 13 lies on the graph of y equals 4x minus 21, what that means is when I plug 2, negative 13 into the equation, the left-hand side will equal the right-hand side. So let's find out if that's true or not. So we're going to have negative 13 equals 4 times 2 minus 21. And so we're checking here. We're saying negative 13 equals 8 minus 21. And so we're going to do 8 minus 21, which happens to be negative 13. So check, this one checks out, which means we're going to write it out this first time. Negative make you write all this out. But for this one, I want you to say yes to negative 3, the graph of 4, I should write y equals 4x minus 21. The other ones we're just going to write yes or no, but this one I want you to write out the full meaning of it. So let's check. We're going to do number 3 together. So here we're going to do 5 halves. This is a question mark. We're checking to see if this does equal 6 times 2/3 minus 1/2. So I've got 5 halves, which is 2.5, right? And then here I'm taking 6/1, and then let's simplify this. And I've got 4 minus 1/2. Well, 4 minus 1/2 is 3.5. 5 halves is 2.5. So those don't equal. So this one is no. So no, and it would be 2/3, 5 halves is not a solution, or it does not lie on the graph of the line y equals 6x minus 1/2. All right, let's check these. On your mark, get set, go. It's a race. So we're checking -3 times -6 minus -3 equals, does it equal 15? So here we've got negative times the negative. Careful with all your negatives on this one. Negative times the negative is going to give us a positive. We've also got another positive, and that's going to tell you right there that doesn't equal 15. So 21 does not equal 15. Our next one, we've got -2 times 0 plus 9 equals 9. Well, does it? 0 plus 9 equals 9. 9 equals 9. Check. Yes, that one works out. And on the back. So on the back, we are plugging 1 in for y. So it's going to be 1 equals -1. And so 1 equals 1. Is that true? Yeah. So this one is yes. Let's check, that works out. And then here we've got 4 times 3 plus 5 times a -2. Does that equal 3? So here we've got 12 minus 10. And so we've got 2 does not equal 3. So this one's a no. All right, let's look at the next one. Number 7, this time we're looking at tables. So it says, which table or tables of values could be generated by the following equation? So we've got this equation and it's just asking us, so which of these tables of values could be generated by this equation? Well, what that means when you do is just plug it in and figure it out. So I'm going to say a couple things here. So 1, if you find one ordered pair that works, you have to check at least one more. You have to find at least 2 in a table. And then if you find at least 2 that work, then you can circle that table. So I'm going to say that again. If you find one ordered pair that works, you have to check at least one more ordered pair to verify that that whole table could be generated by that equation. If you find one ordered pair that does not work in the equation, then you can cross off the whole table. Okay, so here we go. I'm going to check this one first. That looks pretty easy with a 0 and a 5. So I'm going to do 2 times 5 minus 5 times 0. Does that equal 10? Yes, because I see here it's going to be 10. That's going to be 0. 10 equals 10. Check. Okay, so the next one I'm going to check this one and see if that one works out. So next one I've got 2 times 10 minus 5 times a -2. Does that equal 10? So here I've got 20 plus a 10. And so right now I can already tell, right? It's going to be 30, which does not equal 10. And so this one, because this ordered pair does not work, this table's not going to work. Let's look at our next one. So our next one, we've got this ordered pair. So let's check this one out. So we've got 2 times 0 minus 5 times -2 equals 10. And so here that goes to 0. Then I've got 10 equals 10. All right, so that one worked. Let me find, let's do, I'm gonna try this one, 110. So then I've got 2 times 10 minus 5 times 1. Does that equal 10? So here I've got 20 minus 5, which is going to be 15, which does not equal 10. So this table doesn't work either. Well, let's find out if C works. So here I'm going to try 0, 5 first. That's pretty easy. So I'm going to have 2 times 5 minus 5 times 0 equals 10. And that's question mark. That's going to go to 0. So I'm going to have 10 equals 10. Perfect. That one works. I'm going to go ahead and try this 210. So then I've got 2 times 10 minus 5 times 2. Does that equal 10? So I've got 20 minus 10 equals 10, which is 10 equals 10. Check. And because we've got 2 of those order pairs that satisfy the equation, you can safely assume that C will work. So our answer for this one is C. All right, let's finish up with our 2 word problems here. And it says, Jonathan bought a new computer for $1,440 using the electronics store's finance plan. He will pay, oh my goodness, I'm very tired. He will pay $96 a month for 15 months. Write an equation Jonathan can use to find out how much money he still owes after each month of the plan. So I would like for you to pause the video and see if you can figure this one out, and then I will walk you through it. But I want you to pause it and see if you can figure it out first. All right, so on this one, what I want you to think about is almost like draw yourself a little graph. And I want you to think about, like, over here's your money and your debt. And this is going to be time in months. Okay. And so how much money do we owe at no months going by? So no months going by, we go out and buy this computer, and it's going to cost us $1,440 up here. How much are we paying every single month? Like, what is our slope? How much are we going down every single month? We're paying 96 bucks. So we're going, down 96 over 1, down 96 over 1, down 96 over 1, down 96 over 1, until we get all the way over here. And how many months? It's going to be 15 months. This one's going to be 15 when we finally owe $0. So we've got, if you wanted to, you could actually figure out your equation from those 2 ordered pairs, because you've got 0 and 1,440, and then you've got 15, 0. You could totally do that because you could find your slope, and then you already have your y-intercept. But guess what? They already gave us our slope. So we're going to use that. We're going to use the information from the problem. So what that means is that our equation, we've got debt. Could also do like money owed or something like that. So debt is going to be negative 96 per month plus 1,440. I've had some students that don't like to write it like that, and they like to think about it in terms of how we talked about it, where it's going to be 1,440 and they're subtracting off 96 bucks every month. And so you can do that too. Either one, I don't care. Whichever one you want. So then not number 9. This should have gone up here. There's your equation. All right, so then it says, how much will Jonathan owe after he has made payments for 3/4 of a year? Well, 3/4 of a year is how many months? And I'm hoping you're saying 9. 9 months is 3/4 of a year. And so we're going to plug that in. And so it's going to be 1,440 minus 96 times 9, which I don't know what that ends up being. Okay, well, you can put it in your calculator. We could also do a little math over here, right? 96 times 9 and figure that out. So we're going to subtract that off. So feel free, if you would like to do that, you can also just put it in your calculator. So 1,440 minus 96 times 9, we should be getting 576 for that. So that's how much money Jonathan's still going to owe after he has paid for 9 months. All right. Last question here. Our last question, it says Terry earns, I gotta move my paper. Terry earns 12 bucks an hour at his job and he has $82 saved in his bank account. Write an equation to model this situation. All right, so we've got money, like money in your savings account. So I'm just gonna say M equals money. So M equals money saved or money earned. How about money earned and saved? Okay, so M equals money. How much are we making per hour? 12 bucks per hour plus $82. That's how much money he has. How many hours would Terry have to work in order to purchase the new TV he's been wanting that costs $869? Okay, this is also if we live in La La Land where we don't have any other bills to pay. So apparently Terry must be living with his parents where maybe your parents don't require you to pay for anything. And so he would get to, we're assuming that he gets to put every penny towards his TV. Anyway, so we're gonna go ahead and plug that in. We're gonna have 869 equals 12 hours or 12H plus 82. So as you're solving that, you should be bringing the 82 over and then you're dividing by 12. So if we bring our 82 over, we should end up with 787 equals 12H. Now divide both sides by 12. And on this one, it looks like we are getting H equals 65.583 repeating hours. Well, how many hours is that? So how many hours would Terry actually have to work in order to get the TV? That would mean 66 hours in order for him to actually be able to afford it. And again, assuming he lives in false reality where you have to pay for nothing and you get to put 100% of your paycheck into your savings for your dream TV. Okay, that's it. Thanks for tuning in, guys.